Hello, during this session I'm going to be considering how we have perceived our universe in the past with Olber's paradox and how we perceive our universe today. So let's start off with the past. Olber's paradox is named after Heinrich Wilhelm Olber, who is a German astronomer, and it's also called the dark night sky paradox. And it argues that it's odd that our night is dark when some of the assumptions we have for the universe at the time were maintained. Now these assumptions, Newton's assumptions as it happened, this is the premise, is that the universe is infinite, the universe is uniform, and the universe is static. So if we expand on that, it means that if the universe is infinite in size, it goes on forever. The stars fills the universe uniformly, and each star has a set luminosity. It doesn't really change in any way. So these are the old premises of our universe. And if we look at these and think about it, so if the universe is infinite, then in every direction you should see a star, and that even though there should be stars further away which are dimmer, there'd be much more of them, and therefore these two things would cancel out. In fact, if we look at this mathematically, the argument's still valid. If we think of a sphere, distance r from us, and this is one shell, okay, the shell of this sphere, the brightness of one star in this shell is proportional to 1 over r squared, but the number of stars in a shell of thickness t is also proportional to r squared. So all this means that the conclusion is the night sky should be infinitely bright, and clearly it is not. So why is that the case? Well, there's some problems with the premise. The problems are the universe is not infinite, light is absorbed before it gets to us, the universe is not static in terms of speed, and the universe is not static in terms of evolution. So let's just expand on each of these points. First of all, when we say the universe is not infinite, we mean it began with the Big Bang. There's a process here. So the Big Bang meant that it started from nothing, it's expanding out. So that means it's not infinite, it is finite, because it must be finite because it started from a finite beginning. In turn, the universe is expanding, so therefore it is not static. It is also not static as stars evolve and will not produce light forever. And light is absorbed, but if light is absorbed, it warms up the object and so re-radiates in lots of different directions, which kind of are the reasons why we don't have an infinitely bright sky at night. So there's the old thinking and the fact this is fixed with some new ideas. Now the new ideas have led to us to have some cosmological principles, some features which we think are absolute for our universe. We have the homogeneity principle, which means on a large scale the universe looks uniform, and the isotropic principle, which not one direction is special in comparison with another direction. Notice I put principle 1 at the top there. We'll ignore that for now. So if I expand on those 2 points a little bit, the implications of the homogeneity principle is that the universe has no edge. If it had an edge, it would look different if you're close to the edge as from far away from the edge. So that eliminates the idea of an edge of the universe. The isotropic principle, the universe has no center, because if you did, observing from the center would have a different image to observing from any other point. And the cosmological principle means that in whatever direction we look at, the distribution of objects should be pretty much similar. So there's my final cosmological joke, but these are things to think about when considering how we've perceived our universe over time. I hope that helps.